Nikhil.
Amrita, Siley.
Present. PERT.
What is PERT?
Project evaluation.
And review technique.
PERT is a method used to analyze the involved tasks in completing a given project.
The time needed to complete each task.
And to identify the minimum time needed to complete the total project.
PERT was developed by the US Navy for the planning and control of Polaris missile program, and the emphasis was on completing the program in shortest possible time. In addition, PERT had the ability to cope with uncertain activity completion times. Example, if an activity had 4 weeks to complete, it would be completed between 3 to 8 weeks. Now, let's learn some concept using example. This is undirected graph and directed graph. In an undirected graph, pair of vertices representing any edge is unordered, whereas in a directed graph, each edge is ordered.
At that time, critical path is a very important management tool that can be applied to many situations. A critical path is finding the longest path between two nodes in a weighted graph. Now let us see what is a weighted graph. Every edge in the graph is assigned a value. The weight of the edge is positive value that represents the cost or distance between vertices, as you can see in this example.
Wow, this is so interesting. Let's learn some more.
Let's learn something more. Weight value of each edge is the time it takes to complete the activity. Cycle is a path in which first and the last vertices are the same.
Number of tails adjacent to a vertex is called the in degree, and the number of heads adjacent to a vertex is its out degree. In short, it is the number of incoming calls and the number of outgoing calls.
Formally, a PERT graph is a finite graph with no parallel edges or cycles in which there is exactly one source and one sink. Now here's an example of figure A having 10 activities or edges. Every project contains several activities which have to be followed in a particular order. In this, V1 denotes the start of the entire project and V6 denotes its completion. In the given figure, we can see that before the activities V3, V4 and V3, V6 gets completed, we should first complete V1, V3 and V2, V3. Similarly, V5, V6, V3, V6 and V4, V6 must all be completed before completing the entire project. Let us associate the earliest completion time for every activity. Start, that is TE of V1 is equals to 0 and TE of last activity is equals to TP, where TP is the sum of all durations for path V1 to Vj. The latest time of an activity is the time in which an activity can be completed without causing a delay. In the PERT graph, the first node and the last node have equal TE and TL values. So now the PERT graph of our example with its TE and TL values is given. After having completed the TE and TL values, we can determine its critical path. Critical path is a path from the source node to the sink node such that if any activity on the path is delayed by an amount of time t, then the entire project is delayed by time. For each node on critical path, the TL and TE values are equal. For the graph in our example, the nodes on the critical paths are V1, V4, V5 and V6, and the critical path is V1, V4, V5 and V6. Nodes that are not on the critical path have a slack time associated with them. In our example, node V3 has a slack time of 1 day. In order to reduce the earliest completion time for the project, only those activities on the critical path must be speeded up. Representation of a PERT graph is now given here. A structure of a typical event node in this simple linked list will have the form where out is a pointer to the list of its outgoing edges, in is a pointer to a list of its incoming edges, TE is earliest completion time, TL is the latest allowable completion time, and link is a pointer to the next event node in the list. The assignment P pointer node creates an event node of this type and stores in an address P. We shall also need a list of edges whose typical node is of the form
but I didn't understand how exactly to find out TE and TL, that is earliest completion time and latest completion time. Can you please explain me?
Yeah, Balle Balle. I'm glad you asked that question. Let's find it out.
With the given figure, the basic concept of sink and node and source node is clear here. That is, source node is V1 and sink node is V6. Let us look up for the TE of V5. Look up for all the paths from V1 to V5. We have 3. V1, V2, V5, V1, V3, V4, V5 and V1, V4, V5. Take the sum of the weights associated with each path, that is 3, 5 and 6. Look up for the maximum of the sums. Here it is 6. There you go. 6 is the earliest completion time for node V5. Easy, na? So, it's homework time. Find the rest T values for all the required nodes. Let us find out the TL of V4. Look up for the paths from V4 to last node. We have V4 to V6, V4 to V5 to V6. Take a sum of the weights associated with each path. That is 2 and 3. Look up for the max of all sums. Here it is 3. Find the earliest completion time by the previous method for V6. Now here comes the final step. Put down the values required in the formula. That is TL of 4 is equals to TE of Vn minus max of TP. Here TL of 4 is equals to 8 minus 3 is equals to 5. Yepe, there you go. 5 is the latest completion time for node V5. Easy, yeah? And now it's homework time again. Find the rest TL values for the required nodes. The answer